more feature. And currently, the app is available, and after 2 years, we can say that we refactored a lot of code. The issue that we had when we started to approach to these problems was that we need to deliver new features, but we still have to fight with old code, legacy code. In order to maintain the same behavior of the app, we need to not only refactor the code, but to be sure that what we will deliver will have exactly the same behavior of the old features. So as soon as I started, the first thing that I did is to write a lot of UI tests in order to be sure that the behavior of the app was tested. The first thing that I would like to say is that the UI test, when you are writing UI test, the UI test should be agnostic. So you are testing the behavior of the app, not the implementation. So when you start the refactoring, you are writing your Espresso test. Of course, your Espresso test, when you run your Espresso test, you are expecting to have a green light. After that, you start the refactor, and because of some issues, you can expect that your UI test is failing. So in the second time, you concentrate to the process of the refactoring the business logic, and as soon as the business logic is refactored, you run the UI test again, and you will have the green light. This is why I always say that the UI test should be agnostic. And we know the manner in which different tests are made, and we know that we can write tests in different levels. We have the low level in which we can find the faster tests, are the normal unit test in which we are testing a single unit of the code. In the higher level, we can find the integration test, and finally, the UI test. For different levels, we are covering different sets and different cases of our app. As I told you, in the low level, we can find the unit test, integration, the UI test. Higher we go, and bigger is the set that we are covering. Of course, UI tests are very slow, and this is why we would like to find a manner in which we can make this test faster. So starting from the low level, as I told you, we can find the unit test, and unit tests are used to validate your app behavior one class at a time. And when you are writing code, you are opening a PR, we are expecting that, especially when you are writing the business logic of your code, you are expecting, of course, to deliver unit tests. In the middle level, we can find the integration test that you can use it to validate the interaction between levels. And these tests are normally, you are running this test normally with different framework, Espresso or directly in the device or in the emulator. And in the higher level, you can find the UI test or end-to-end test, and that we are using this test to validate the user journey, so the real behavior of the app. And this is more or less the framework that we are using when we are trying to cover different levels of testing. In the raw level, we can use Mockito and Robolectric, or in the higher level, Espresso and directly the application, the Android at runtime, so the device or the emulator. The issue is that all these frameworks are using the same common pattern. So given a condition, you would like to test that something is happening, and but what is the problem? So why using a lot of framework to do more or less the same thing? Of course, in different level, but you are doing more or less the same stuff. So why you should learn different frameworks? So you have a big, you can face with a lot of problems in this case. So we can find a lot of framework with different APIs, and you don't know where to deploy your test. Okay, the unit test you use to deploy in your laptop, the integration and the Espresso test in the normal devices. But why writing more or less same things in different level and deploying in different kind of hardware or platform? So if we try to see a bit the history in Google, we can find that also Google had a lot of confusion and in the manner in which they was testing. So starting for 2011, they started with a lot of frameworks, and last year they decided to unify or to try to find some method in order to write the same code, but using the same code you can test all the levels. So they delivered in 2011 the Android test library. The Android test library is trying to unify tests with in different level of the test pyramid. So the Android test library is composed by more or less 4 parts. So we can find the JUnit, in which we can find the runner, so which we normally use in our unit test, normally also with the rules, so in which we can find the ActivityTestRule and the service-test-rule. Later on, we have the core. The core of the library are the most innovative stuff that they have introduced. They have the application provider, which give you the possibility to retrieve the context, the application context in your test, and the activity scenario and the fragment scenario. The activity scenario and the fragment scenario are used in order to drive your activity or fragment in different in the different level of the status of the activity in one case, in a fragment in another. So you can test when your application is created, stopped, recreated, and so on. The same for the fragment. And for the third part of the library, we can find Espresso. And so you can use the normal Espresso framework with the action matchers, etc. And they introduced also another assertion framework, which is truth, and is a smaller API than the normal AssertJ. And in fact, you can see in normal AssertJ, you are asserting equals that the view is visible, and that the second row is written with true and is more readable and more compact. And also, you can find the subjects. Subjects are the classes that you can use in order to test more or less some specific actions. For example, we have subjects for notifications that are exactly, you can find inside that library, or you can extend subjects in order to test your own class or behavior. Apart of that, you can find more other libraries that you can use it. For example, the test run a screenshot, in which you can, when you are running your test in your device, you can take a screenshot, or filters that are very usable. For example, if you have different build variants, you can specify some filters in order to run only some classes for some build variants and some other for some other build variants. So if you have to deploy your app for different markets, for example, can be very useful when you are running a URI test. And with the Android test library, they would like to achieve the problem to have different frameworks. So they would like to unify this API in order to include instrumentation and normal unit test. It means that if you write a test, for example, in Espresso, with the same kind of library, you can expect to run this test in your continuous integration using Robolectric. So we have a lot of news, a lot of new things with the androidx library. As I told you, we can use the new scenario API to launch the activity of the fragment and to drive the activity of the fragment in different in the different moment of the activity, or you can use also Espresso to make some view interaction, and through to assert that your view, text view, or whatever is displayed in the screen. And also later on you can run your test if you don't want to use the device or an emulator. You can run your test in the Java virtual machine. The androidx library is still ongoing. They are still developing, but there is a project that is called Project Nitrogen that we can find some proof of them, of this project in the androidx unit code. And when you run your unit test, automatically the runner knows where to deploy your test. For example, if you have an emulator or a device attached, it's using the normal androidx unit class runner. Otherwise, it will run your unit or UI test with Robolectric in the JVM. This is a part of the source code of the androidx unit runner. Just a little bit of introduction about Robolectric. Robolectric is a framework that provides a Java virtual machine, that run in the Java virtual machine, that give you the possibility to emulate the behavior of a normal Android device. Using Robolectric, as I told you, you can run your UI test, in the Espresso test directly in the continuous integration without additional setup. This is not totally true, because you need to provide to Robolectric a lot of configurations. For example, everybody knows that testing for tablet is different for testing an application in a normal mobile phone, because we need to deal with different screen sizes, with different, for example, if we need to deal with the rotation of the screen. So you need to add some additional setup in Robolectric that we can see later. So now I would like to show some code examples. So I switch here. So here we have a normal application that you can find in my GitHub repository. It's a simple app that is retrieving something from the network and from the GitHub API, and it's retrieving a list of repositories. And after that, after retrieving from the network, it's displaying with a recycle view the data. So we would like to, this application is unit tested, and you can see normal unit test in which we are dealing with to verify some condition. What we would like to achieve is to run the Espresso test. First of all, I would like to show you the manner in which we are running the Espresso test directly on the device, and we would like to achieve the same result from the terminal, and running with Robolectric. So let me deploy. So currently, with this test, currently we are testing that the data is retrieved from the network, and after that we are asserting that we have some elements. So what you can see here is a normal wrapper between this condition. So I like to use this format in which you are given a condition. When something is happening, then the user can see the result. So if we go inside these classes that are only wrapper between conditions, for example here, we have that, for example, when we are retrieving something from the network, here I'm using mock web server, we are returning some data that currently is not mocked, but is a stub. And after that, we have the when condition. So when we are launching the app, as I told you before, currently here I'm using the activity scenario. The activity scenario, I'm using just to specify which activity I would like to launch. And there are some issues, especially when you are using Espresso with Robolectric. Espresso is, you can use the idling resources, for example, if you have an async task that you would like to test. But if you are using it with reactive Java and with other, asynchronous tasks, for example, here I'm using Maverick from Airbnb, it's very difficult to synchronize the task. So there are also some issues that we need to find out because Robolectric is still not ready to be used, especially in async. But I found a lot of issues, especially, for example, when you are using a fragment manager or when you are using a transactions, etc. So, as I told you here, I run in this test, given a condition when the application is launched, you would like to verify that in some case you have an error, or you would like to verify that you have some element in the list. So I already ran the test, and everything was fine. So with a little bit of magic here, we can add this test also in Robolectric. The issue is that if you would like to run your instrumentation test, the source code should be in a directory, that is the androidx.test directory. Problem here is that the unit test is in total another folder, so you would like not to mix this code from one directory to another one. So the trick that you can use is you can add directly your path. You can specify in your Gradle file, you can specify where the UI test path is, and you can add also other DS4. For example, in this case, I'm also saying that the test directory is composed by the normal source dir plus the other dir in which we have the instrument test code. There is another additional issue, because if you have different build variant, for example, of course, the Android test folder is named Android plus the build variant name plus test. In order to add the path to the normal unit test source code, you can add a Gradle script in which when Gradle is synchronizing, so when you are switching a build variant, is adding automatically, depends on your build variant name, is adding your source code directly, appending, directly to the unit test folder. So currently I'm trying to run this test, which is exactly the same, so I'm changing nothing, exactly the same test to Robolectric, so without a device, and I'm expecting more or less the same result, hopefully. Okay, everything was fine. So if we go now to the test result, which is the report that is generated automatically when you are running the unit test, you can see that the test that we wrote for Espresso was executed, and we have the green light. This is a very cool step, because in this manner, as soon as we add this test in the continuous integration, we can test our feature directly in the continuous integration. So we are 100% sure that when we are pushing code, merging code, or when we are refactoring something, the behavior is still maintained. So as I told you, when we have a lot of build variants, it's very difficult to differentiate this UI test. So we found different solutions. The first solution is using the Gradle script and adding appending the directory of the instrument test at runtime directly to the unit test folder, or you can use another solution, which are the JUnit category. So you can tell to the UI test, specifying some with this category annotation, that the test can run or not. So you can also use the shared test folder, but I don't recommend to do it because when you are sharing tests between, especially when you are sharing resources between a unit test and UI test, something can go wrong. And this is the script that I told you before, in which we are using a pattern in order to identify which is our build variant name. And as soon as the build variant is found, we are adding directly to the Java source dir. And when you are using the category, you can specify directly, as I told you before, directly in your class, which test can run or not directly with some build variant. This can be very tricky because if you have a lot of build variant, using the you have to specify a lot of categories. For example, you can specify one category only for run, for example, in a German market, or one category for another market. But a category is only an interface, so it's something that the JUnit can recognize at runtime, and but it can be very tricky when you have a lot of build variants. There is another issue. So when you are running the Espresso test, it's very easy to attach the debugger, because you can use it in a normal way. So you attach the debugger, you run your application, and the debugger is working. When you run the test by the command line, can be difficult, because if you would like to debug, because sometimes Robolectric and Espresso has some incompatibilities. So if you would like to debug with Robolectric directly from the command line, you have to attach a remote debugger, and you have to specify to your Java virtual machine to create to attach to this remote debugger using a socket. This is out of scope of this presentation, but you can find this article directly on Medium. And so just to have a better understanding what we have now, try to write the same test in Espresso and Robolectric can be very tricky, because we have not a lot of documentation. Robolectric, as I told you, has still a lot of bugs, especially when you are using the fragment manager, custom views, or async tasks. We found a bug time ago. Currently, maybe it's fixed with 4.3 release. Robolectric, when it's running the application, was drawing the view with 0 height, so it's not possible to assert. There was a trick in which when you specify the mean height, everything was working fine, but was kind of fixed that I think that was not very, very cool to do. It's very difficult also to understand in which manner to create, to share a report between Espresso and Robolectric. 5 minutes ago, I showed you the normal report that you can see using the unit test. Using Robolectric, you can attach different report tasks, but there is no guideline in order to see in which manner we can unify this report. With the release of the Nitrogen project, we would like to expect, of course, a more stable API and more documentation, especially in which manner we should integrate every run environment. This is more or less what they would like to achieve. So you have your local environment or the continuous integration, and when you run your test, you need to specify where you deploy it. So we will arrive in a point in which the same code as I showed you before can run in your virtual or real device, in the JVM, using, for example, here Robolectric, in the Google Cloud or in the Firebase Test Lab. And you can find here some sources in which there are some other examples, and it's more or less this.